It's like I don't care about nothing, man. Yeah. Oh,
So this video is going to be going over the same exact things I went over in the last video. The only difference is instead of using a calculator, I'm going to show you exactly what you would do if you are trying to use a ZTable. So I hope you enjoy. So just in case you skipped right to this video so that you could see the ones with the chart, just to make sure you remember the z-score formula has the x, which is the observed value, minus the mean over standard deviation. So your mean is always going to be 0. Anything that goes to the right will be a positive z-score. Anything that goes to the left would be a negative z-score. So now we're doing this problem where it says, suppose that SAT scores among U.S. college students are normally distributed with a mean of 500 and a standard deviation of 100. What is the probability that a randomly selected individual from this population has a SAT score at or below 575? So the idea with this one, first you have to find your z-score. So we plugged in 575 for the x, 500 for the mean, and 100 for the standard deviation. When I do this, I get 75 over 100, which is 0.75. So now I'm going to show you how to find your z-score based, or your percentage based off that z-score using a chart. So the z-score that we had was 0.75. So if that's the case, I'm going to go down to 0.7, go to the right until I get to the 5, and I get this percentage of 0.7734. So the percentage you're going to see is 0.7734, which is also the same answer we got when we used a calculator. So just like I said, it ended up being the same exact answer. Now, underneath it, where you're dealing with how many college students that has 28,412 are expected to score better than 575, we do the exact same thing. So we would do 1 minus the percentage we just found, because we want everything on the right side now instead of everything on the left side. And when you find the actual amount of students, you just take the total amount of students times the new percentage that you just found by doing 1 minus the one you had before, and we get 6,438 students. So the next one I'm going to show you is number 2 on page 17. We're looking at part A. What number represents the 65th percentile? What number separates the lower 65% of the distribution? So using that 65th percentile, we're going to be able to find our z-score. So I will show you how to do that on your chart, which is on the very last page. So since we want the 65th percentile, the way we find what our z-score is going to be is by finding where we first see 0.65. So if I'm going through, the first place I see that is right here. So if I went down, I would be at 0.3. Then it goes all the way to 0.09. So my z-score will be 0.39 based on the percentile of 65th percentile. So you'll notice that we ended up with the same z-score as when I used a calculator. We had the z-score of 0.39. So when we do this, I know that because we're trying to find a specific number, we still use the z-score formula, but it has to now equal what we just found the z-score is going to be. So we would have x minus 35 over 6 equals 0.39. Trying to get x by itself, so the first thing we did was multiply 6 to both sides. So now you have x minus 35 equals 2.34. Add 35 to both sides, and your answer is x equals 37.34. So I'm going to help you find the z-score for part A for number 3. What is the minimum score necessary to be in the top 15% of the SAT? Remember that when we're looking at everything, we want everything on the left side. So since this says the top 15%, I would need to find the percentage on the left side, which is 0.85. So the 85% is going to be what I use to find my z-score. So I'll help you find that, and then you would do the same formula that you did up here, where you're setting it equal to whatever the z-score you just found. So we want a percentage of 0.85. So the way that we would find the z-score we want is by looking for the first place we see 0.85. And if I did that, it would be this right here. So your z-score would be 1.04. So that would be your z-score that you would use. Now I do want to show one extra example. I want to show part C for number 2 so that you can see exactly what you would need to do if you were using a ZTable to find the probability in between two numbers. So first thing you have to do is find your z-score. So I'm going to pause it, put in the z-scores that you would use, and then show you how to use the ZTable. So for this problem, the two z-scores I'll be dealing with is negative 1.17, and the other one would be 0.5. So I'll show you what to do with a ZTable now. So to find a negative z-score on this chart, all we have to do is find it as if it were positive. So 1.17, 1.1, go over to 7, and then I'll have to subtract it by 1. So we subtracted by 1 to now make it the negative, because we want the opposite of what it's showing. So let me show that on the paper. So when I subtracted it by 1, I got 0.121. So this would be 12% of the data when you're dealing with the negative 1.17. Now for 0.5, I just go to 0.5 on the ZTable, and it will be the first one here, and I get 0.6915. So I'll put that on the paper and show you what you need to do to find the percentage in between them. So I have both of the percentages from each one. So this one was from the negative 1.17. This one came from the 0.5. So what I do with these two values is I subtract them. So I do 0.6915 minus 0.121, and this will get me 0.5705. So roughly about 57% of our data would go inside of there. Now if you have a calculator, you could have also used the calculator and made this your lower value, this your upper value. So that's the end of the video. You'll notice that even though I use a ZTable, I was getting, if not the same answers, very close to the same answers. So I hope you found it very helpful.